Okay, welcome to our test review. I want you to remember MapMan. MapMan tells me that if I multiply same bases, I add the exponents. Here's an example of that. I have x to the 8th times x cubed. I have the same base. They're both x as a base. So I'm going to add my exponents, and I'll end up with x to the 8 plus 3, which is x to the 11. Now, if I have a power to a power, I multiply, and that's a fact. Here's an example of that. This is called a power to a power, and I multiply, and I get x to the 24th. Okay. Just a little reminder. Now, let's simplify our first problem. And I know that multiplication is commutative. I can change the order of my factors. So I'm going to first do my numbers. I have 5 times 4, which is 20. I have the same base. I have an x, and I have another x term. So I know that x to the first power, remember I can consider that to the first power, times x to the first power is x to the 1 plus 1, which is x to the second power. Now I've got a y factor, it's the y base, so y cubed, and I have another one, y to the negative 1. So I know that y cubed times y to the negative 1, I'm multiplying, so I'm going to add the exponents, and I end up with y squared. Okay, and I'm done. My number's out in front, it's alphabetized, it looks good. No negative exponents, fantastic. Now I'm going to simplify a squared b to the negative 3rd power, all of that to the negative 2nd power. This is called a power of a product. It's considered a product because I'm actually multiplying this factor, a squared, times this factor, which is b to the negative 3rd power. So some of my classes call this the Badoop-Badoop rule, the Badoop-Badoop rule. I'm going to rewrite this as a squared to that power, which is negative 2, times b to the negative 3, 3rd power, to the negative 2nd power. Okay. Now I've got 2 powers to a power. I do my exponents first because I do my exponents before I multiply. That's what PEMDAS tells me. So this is a power to a power, and I end up with a to the negative 4th. Power to a power, multiply, and that's a fact. Times b to the, what's negative 3 times negative 2? Gives me b to the 6th power. Well, it's not simplified because I have a negative exponent. So a has a ticket to ride. I can put the whole thing over 1, if that helps me. A has a ticket to ride. It wants to go into the denominator, so I end up with a to the 4th power. And b is happy where it is, with its positive denominator, b to the 6th. Okay. Let's simplify. This is actually a power of a quotient. Quotient means division, or it's like fraction. So I've learned that my power of a quotient rule tells me that I'm going to take my numerator to the exponent all over my denominator to the exponent. But when I have a negative exponent, right there, I can use a shortcut. And the shortcut tells me that I can flip the quotient and change that to positive. So ready? Negative exponent. Yikes, it's a negative. Now what am I going to do? I'm going to use the reciprocal. Change it to positive. That's just what I'm going to do. Watch how we make this work. I've got 4y over 3x. That's my reciprocal. I'm flipping it. And I'm taking that all to the positive 2nd power. Now my quotient, my power of a quotient rule tells me that I'm going to have 4y to the 2nd power over 3x to the 2nd power. 4y to the 2nd power over 3x to the 2nd power. Now I'm going to use my Badoop-Badoop rule, as one of my classes affectionately calls it. Badoop-Badoop rule. When I simplify, I end up with 4 squared over y squared. 4 squared times y squared, all over 3 squared times x squared, which ends up being 16y squared over 9x squared. I don't have same bases on top and bottom, so it looks good. There's nothing more to do. I'm done. Okay, let's simplify this one. It's another power of a quotient rule. It's another Badoop rule. I'm going to take my whole numerator, take it to the fourth power, all over my whole denominator to the fourth power. Let's rewrite that. I've got 4x squared y to the fourth power, all over 2x to the negative second power to the fourth power. Now I'll simplify my numerator and my denominator. Keep on simplifying after that, and we'll be done. So on top I have, it's another power of a product. Ba-doop-a-doop-a-doop. I end up with 4 to the fourth power, x squared to the fourth power, times y to the fourth power. Make sure you write this step. All over 2 to the fourth power times, x to the negative 2 to the fourth power. Let's keep it going. I end up with 256. Got a power to a power here, so I'm going to multiply my exponents. X to the 8th, y to the 4th. All over 16. Let's multiply these exponents. I get x to the negative 8. What's cool? I see that I have the same base on the top and the bottom. I'm going to be able to simplify those using my quotient rule. My quotient rule tells me that something, x to the 8th over x to the negative 8th is going to be the same thing as x to the 8 minus whatever's on the bottom, negative 8. So if I leave change it, that turns into x to the 16th. Good. So let's keep that in mind. Right now we're going to simplify. So we end up with 16, because 16 goes into both top and bottom. And then x to the 8th over x to the negative, so I've simplified those. Let's simplify those. We end up with x to the 16th. And I still have a y to the 4th on top. And I'm done. Okay. Here I don't have any, I have no factors with the same base, but I do have some negative exponents, so let's handle that. Let's see, 4 is happy where it is. A is happy where it is. B has a ticket to ride. It's going to the denominator. C is happy where it is. X in my denominator has a ticket to ride. It wants to go up. X squared. And that's my variables are alphabetized. My numbers up front. No negative exponents or zero exponents. It looks good. I need to write an expression to represent the area of the square. I know that when my formula for a square, my area for a square is my side length squared. I see my side length right here, so this should be pretty easy. My area for a square is 12d to the 8th e f to the 13th, and I'm just going to square the whole thing. Okay. If I actually had asked you to simplify it completely, which I think we'll do, actually. All right. Let's simplify it completely. We're going to go 12 squared times g to the 8th squared times e squared times f 13 to the 13th squared. 12 squared times d to the 8th squared times e squared times f to the 13th squared. Let's do our power to power. 144 times d to the 16th times e squared times f to the multiplied, and that's a fact, 26. And that's my answer. Wrong way. Who does this 0 belong to? Just the x. Just the x. And we know that anything to the 0 power is always 1. And I still have that negative out there. My answer is -1.